Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are actually, believe it or not, we are going to finish Chapter 5 today. I know it seems like we just started it, and you're right, because there's only 4 lessons in Chapter 5, so it moves very quickly. But today we're going to use what we've been learning about systems of equations, and we are going to connect that to word problems. And so another strategy to solve word problems is use systems of equations. And so let's go ahead and just jump right into it. In our books, we are on, page number 168, page 168, and we're going to be learning about word problems, how to solve them using systems of equations. First of all, we want to identify. The steps are right there in your book if you're looking on 168. We want to identify, you can also look down here on the screen, what you know and what you don't know. Some of you, that's a really short list, okay, for what you do know, and a really big list for what you don't know. And I'm not talking about like what you know in your mind, okay? I'm talking about in the problem that they give you. So some of you are like, "Oh my goodness, Mr. Steve, that's a lot of stuff I don't know." No, I'm talking about the problem that they give you, okay? This is not a word problem for your life, all right? So I know some of you struggle with this. But first, identify what you do know and what you do not know. So they're going to give you a problem, and you have to figure out, okay, what do I know? What do I not know? Step number 2. And this is where this is a little bit different from some of the things we've done in the past. Look at number 2. Assign a variable to each unknown. In the past, I've told you, and maybe I lied just a little bit, okay? But I've told you in the past that you cannot assign different variables. I said you can't solve it if it has an x and a y. And now I'm kind of going back on that and saying, well, you kind of can't solve it. But with this method, you can solve it. And so in this method, you can actually now assign an x and assign a y. So you're going to assign them different variables this time rather than in the past we've tried to assign them the same variable and kind of do some things with that. But here we're going to actually assign them x and y. Step number 3, we're going to write our own equations, and we're going to connect them like a system of equations. So we're going to have equation number 1 and then equation number 2, and then we're going to solve those. Look at step number 4. Solve the system, and you can use whatever method you want. Maybe graphing would work. Usually graphing doesn't work the best just because your answers don't always come out perfect. You can use substitution if you like that method better, or you could use elimination. Maybe you like to use elimination, and that would be fine. Any of those 3 methods would work. Number 5, make sure you answer the original question. Go back and look and say, okay, now that I solved this, did I answer the original question, or is there a little bit more that I might need to do at the end here? Okay, so there's your 5 steps to solving word problems. All right, here's a word problem. This looks like fun. This one is actually in your book on page 168. Page 168. All right, so here we go. We have the sum of 2 numbers is 71. We could actually just stop right there and we could say, okay, what do we know and what don't we know? Okay, we know that we have 2 numbers. So how many variables will we probably have? 2 variables. And we know that is means equals, and we know 71. So we know some stuff here. We know sum means add. Okay. We could actually write our first equation right now if you want to. 2 numbers, we'll call it x, sum, adding, and y is equals 71. There's our first equation right there. The sum of 2 numbers, that's that right there. The sum of 2 numbers is 71. Done deal. That was easy. The next section says their difference is 13. Whose difference? Well, these two, their difference. So let's do the difference. Well, that one was sum, this one is difference. What's difference mean? Subtraction. And the answer is 13, is 13. And then it says, what are the numbers? So that's what we're trying to find. So going up to our steps, we have figured out what we know and we don't know. We don't know what the numbers are. We do know that added together they equal 71, and we do know that subtracted they give me 13. And then we assigned variables to them. We called one x and one y. And then we wrote our equation as a system. We wrote our equation as a system. So we're ready to solve the system. Go ahead and solve the system. I think canceling elimination is the easiest one to use here because those y's cancel right out. We'll add these and we'll get 2x equals, what is that, 84. 84. And then just divide by 2, and we're going to get x equals 42. X equals 42. Now, let's go back to the original and let's see, did we answer our question? Because that's step number 5, right? Make sure you answered the original question. So here's the original question. What are the numbers? Plural. We only have one number. What do we still need to do? We still need to find what y is. We have what x is. Now here's the way that you accomplish that. You just plug the x in, just like we've been doing. And so we're going to plug in 42 plus y equals 71. We could plug this into either one would work, but I just chose the first one. We subtract 42 from both. That's going to cancel, and we're going to get y equals, and you can do this on your calculator if you want. I'll go ahead and actually do it longhand. I'll borrow. That's a 9, and that's a 2, 29. All right, so there are our two numbers. So the y is 29, and the x is 42. One way that you could check this is you could just add them together, 42 plus 29, and that should give you your 71, right? And then you could subtract them. So you could put 42 minus 29 equals, and that's going to give you your 13. If it doesn't give you those numbers right here, then you've done something wrong, and you need to go back to the drawing board and find out where you went wrong. So that's a good way to check your solutions on these. All right, let's go ahead and do this one. This one's a little bit more complicated. All right, so we're going to sell some peanuts and pecans. All right, so maybe we work at a grocery store and we're putting some peanuts and pecans together and letting people kind of choose the mixture of the nuts there. And so we have peanuts, and they cost $7 per pound, and the pecans cost $10 per pound. Okay, and so I'm just reading the information here. This one's kind of in your book. I modified it just a little bit, but it is in your book on page 170. If you kind of want to follow along there, you can. It's not exactly like it is written in the book, but it's close. So $7 for peanuts and $10 for pecans. Since we can't use P equals and P equals, since they both start with P, we'll call the peanuts, we'll call those N for nuts, and we'll call these C for cans. Right? So we're not going to use the P so we don't get confused on that. So we'll use N for nuts and C for cans. Pecans. You see what I did there? All right. So let's come down here and let's just write those out. So we'll write N equals $7 per pound. N equals $7 per pound. This is what we know. And then the C for pecans equals $10 per pound. All right, so there we go. What else do we know? We know that we're going to mix them together to make 75 pounds of nuts. So that's going to equal 75 pounds. That's a lot of nuts right there. So, that's like a huge grocery store, and they maybe had to have like this big thing in the middle with just a bunch of nuts in there, mixed nuts. And so 75 pounds of nuts. It'd take you a long time to eat 75 pounds of nuts. These nuts cost $8.20 per pound. So this is like when we mix them together, we end up getting that. So they're also going to equal $8.29 per pound. So There's kind of a couple different things. So let's go ahead and let's first of all say what is the known and what is the unknown. Well, here's the known. We got 75 total pounds. We know that the peanuts cost 7. We know that the pecans cost 10. What else do we know? We know how much the mixture cost. And we could say this is the mixed. And the mixed is $8. Actually, let me come back here and we'll call this we don't need to give it a variable. You'll see what I mean in just a second. But the mixed is going to equal $8.20 per pound. Okay? So those are things that we know. What are things that we don't know? Well, look at the question. How many pounds of each? That's what we don't know. We don't know how many pounds of each. So let's call the pounds of each, let's call them the C and the N. Okay? And so the pounds of each, now notice, let's go back to this question some more. They're going to make 75 pounds of nuts. So we know that the pecans plus the peanuts, so we know that N plus the C is going to equal 75 pounds. There's one of our equations right there. What's the other thing that we know? Well, we know some information right here. We know that these mixed things right here, so we know that the mixed nuts are going to equal $8.20 per pound. And we know that together it's going to be, the peanuts are going to be $7, and that's for the peanuts. And we're going to add those to the pecans, and those are going to be $10. And we'll put that in parentheses. Okay? So in other words, I don't know why I put those in parentheses, to be honest with you. And I also don't need the dollar sign really right now. I just don't want to confuse you with what's going on with too much of this stuff, okay? So there we go. That's about as simple as I can get it. All right, so here is our system of equations. There's one more thing that I need to do. Notice that this is $7 times the peanuts, and this is $10 times the pecans. This is actually $8.20 times the mixture, okay? Because that's how much we're going to have when we've got it all mixed together. So what was the mixture? The mixture was 75 pounds. So one thing we need to do here is multiply that by 75 pounds. That will put all of this in basically in totals per pound. So when you multiply that together, you end up with, let me grab my calculator out here. So 8.20 times 75. And that's going to give us 615. So multiply those together, we get 615. Well, let me put it in the same color the other one was. 615. The reason I did that, remember, is because these are being multiplied together. That's being multiplied together. And that needed to be multiplied together because these are the totals. These are the mixtures, okay? All right, so now we're ready to go ahead and solve this. How do we solve this? Well, let's do this one with substitution, okay? Last one we did with elimination, so we'll do substitution. Let's use this one, and we can solve this one very quickly. We'll say N plus C equals 75. We'll subtract C from both sides. That's going to cancel that. We're going to get N equals 75 minus C. All right, now where's that going to go? Now, we solve for N here, so we're going to plug N back into this one. So we're going to get now 7 times 75 minus C plus 10C equals 615. Okay, all I did there was substitute that in for the N. It's the only thing I changed. Look, there's the 7, there's the 10C, there's the 45. Where'd that come from? It came from over here. That's the substitution. Okay? So, I'll change the color again. Let's go ahead and solve this. What do you get when you multiply this together? I don't know. I'm glad I have my calculator out though. I get 7 times 75, and that equals 525. So I get 525 minus 7c. That's me distributing that. Plus 10c equals 615. All right, we can do this next. Combine those like terms. What are we going to get there? 525 plus 3c equals 615. Okay, I just combined those terms. I had a -7 and a 10. Now I'm going to move the 525 to the other side, minus 520. That's going to cancel that. So I'll end up with 3c equals, subtract that, what do we get? 75, 85, 90, I think. 90, I hope my math is right there. Divide by 3, cancel. C equals 30. So what is 30? Well, let's go back and figure out what was C. This is a big problem, so we got to go back and figure out what was C. Oh yeah, the pecans. That was C. Okay, that's where we wrote it down there. So this was peanuts, and this was pecans. All right. So the C, the pecans, is what we got. So now what we're going to do is we're going to plug that 30 back in here. That's the easiest one to plug it into, right? So n plus 30 equals 75. We're going to subtract 30 from both sides. That's going to cancel. We're going to get n equals 45. The number of peanuts is 45. And so let's see, what questions do they want us to answer? How many pounds of each should be used? Well, there we go. We got 30 pecans equals 30 pounds. Peanuts equals 45 pounds. Okay? And there's your solution for that problem. All right. I know it's a lot. There's a bunch of stuff in there. It's words, it's English, it's math, it's confusing. I get it. Try to take your time, go through that. Really, what are you doing here? You're writing an equation and you're solving, actually, you're writing two equations and you're solving a system of equations. That's what you're doing. All right? Go ahead, try some of these practice problems at the end of the chapter. If you missed something, rewind it, try to figure out what you missed. All right? We'll see you later. Have a good one. Bye-bye.